The rotary is powered by a 3-cylinder Hicks marine engine, built around 1920 in Benicia, California, by the Hicks Engine Works, a respected name in West Coast marine power. This particular engine is the model LY32, rated at 45 horsepower, and was designed for reliability in small to mid-sized working vessels. Hicks engines were widely known for their sturdy construction and smooth, steady operation, making them a popular choice among fishermen and boat builders during the early 20th century. The 3-cylinder design offered a good balance of power and efficiency, well suited to long hours on the water. Today, surviving examples like this one are rare, representing an important piece of California's maritime and industrial heritage. The 100-horsepower Chicago pneumatic diesel hit-and-miss flywheel engine is a remarkable piece of early industrial power. Built more than a century ago, this massive engine once served as a reliable workhorse, powering heavy equipment with its distinctive, slow, rhythmic operation. Now 101 years old, it was donated to the people of Mississippi by the workers of the Pascagoula paper mill, where it had faithfully served for decades. Today, it resides at the Mississippi Agricultural and Forestry Museum in Jackson, Mississippi, as a permanent display. Maintained and operated by members of the Dixieland Old Engine and Agriculture Club, the engine continues to impress visitors with its sheer size, craftsmanship, and the enduring legacy of early diesel technology. El motor Deutz Diesel de 6 cilindros en línea con refrigeración por aire es un propulsor reconocido por su durabilidad, eficiencia y bajo mantenimiento. Este tipo de motor se caracteriza por prescindir del sistema de radiador y líquido refrigerante, utilizando en su lugar un sistema de ventiladores y aletas que disipan el calor directamente al ambiente. Gracias a ello, se reduce el riesgo de fallas por fugas o sobrecalentamiento en condiciones extremas. Unlike liquid-cooled engines, it relies on an advanced air cooling system with integrated fans and fin cylinder heads, which eliminates the need for radiators, coolant, and water pumps. This design makes it less vulnerable to freezing, overheating, or coolant leaks, reducing maintenance costs and improving operational reliability in harsh environments. The inline 6-cylinder configuration ensures smooth power delivery, excellent torque characteristics, and fuel efficiency. Known for its ruggedness, low vibration, and long service life, the Deutz air-cooled diesel engine remains a trusted choice for operators who need dependable performance in demanding conditions. The Andoria S320 is a single-cylinder, stationary diesel engine manufactured by Andoria Mott, Poland. It is a 4-stroke, water-cooled design, cooling either by water circulation or evaporation, intended for continuous loads with minimal supervision. Key specifications include a bore of 120 millimeters, stroke of 160 millimeters, and a displacement of approximately 1/810 cc. Its rated output is about 13.2 kilowatts, approximately equals 18 horsepower, at 1/500 revolutions per minute. Peak torque reaches around 84.4 newton meters, attained near 1/200 revolutions per minute. The dry weight is in the vicinity of 330 kilograms. The S320 is valued for a rugged, simple design, reliable operation, and ease of maintenance. It finds common use, driving irrigation pumps, agricultural machinery, simple power generators, and water pumps in remote or under-resourced areas. Beyond diesel, there exist gas variants of the engine, e.g. S320ER1, capable of running on CNG, LPG, biogas, or syngas. These versions retain the simplicity and durability of the base version, making them suitable for rugged, off-grid environments. The intercooled turbo diesel bobber Comet 40 CVT blends rugged design with modern performance. Powered by a turbocharged diesel engine with intercooling, it delivers reliable torque and efficiency. The CVT transmission ensures smooth, adaptable rides, while its bobber styling adds a bold, minimalist edge, perfect for both urban cruising and long journeys. The Deutz F2L514 is a remarkable piece of engineering history, representing the durability and craftsmanship of mid-20th century German diesel engines. Built more than 70 years ago, this air-cooled two-cylinder engine continues to impress enthusiasts with its reliability and distinctive sound. Designed for agricultural and industrial use, the F2L514 powered tractors, stationary machines, and various pieces of equipment, making it a workhorse of its time. Starting a 70-year-old diesel engine like this is more than a technical process. It is an experience that connects us to the past. The preparation involves checking the fuel system, ensuring proper lubrication, and setting the decompression lever before engaging the starter. When the flywheel begins to turn and the cylinders ignite, the rhythmic chug of the F2L514 brings a sense of nostalgia and admiration for mechanical simplicity. Unlike modern engines loaded with electronics, the Deutz F2L514 relies on purely mechanical systems, showcasing the ingenuity of engineers who built machines to last decades. Its distinctive air-cooled design eliminated the need for radiators and coolant, reducing maintenance and improving reliability. Hearing this vintage Deutz engine come back to life after so many years is not only a mechanical triumph, but also a tribute to timeless engineering. The Deutz diesel startup sound, stationary engine evaporator, year 1927, auto-cycle old-timer stationary engine, is a remarkable piece of engineering history that reflects the transition from early industrial power sources to more reliable combustion engines. Built in 1927, this stationary engine represents the innovation of the renowned German manufacturer Deutz AG, one of the world's oldest engine producers, co-founded by Nicholas Otto, the inventor of the four-stroke Otto cycle. This particular machine, often referred to as an evaporator-cooled stationary engine, was designed for agricultural, workshop, and small industrial applications. Unlike modern engines, it required manual preparation and patience to start, a process that produced a distinctive, deep, rhythmic startup sound still cherished by vintage engine enthusiasts today. The combination of slow revolutions, mechanical clatter, and the puffing exhaust gives the impression of raw mechanical power harnessed in its purest form. Running on the Otto cycle, this old-timer engine embodies the shift from steam-driven machinery to internal combustion. Its durability, simple construction, and reliability made it indispensable in rural economies of the early 20th century. Today, preserved and demonstrated at vintage machinery shows, the Big Deutz 1927 stationary engine is celebrated not only as a technical artifact, but also as a living memory of industrial heritage, reminding us how early engines shaped progress. The Rolls-Royce Eagle Diesel Plus 7C is a heavy-duty diesel engine developed for commercial vehicles, combining strength, durability, and efficiency. Part of the Eagle engine family, it was designed to deliver reliable performance for long-haul trucks and industrial applications. The Plus 7C variant represented an upgraded version with improved fuel economy and enhanced torque output to handle demanding loads. Known for its robust engineering and long service life, the Eagle Diesel became a trusted choice in transport fleets during its era. Rolls-Royce's focus on precision engineering ensured that the Eagle Plus 7C maintained high standards of power, dependability, and operational efficiency. A circular saw powered by a Bernard engine is a practical and efficient tool for processing firewood. The setup typically consists of a robust circular blade mounted on a sturdy frame, driven by the dependable Bernard petrol engine, known for its durability and steady performance. This combination provides consistent cutting power, making it well suited for handling logs of varying diameters. Farmers and households often use such machines to quickly convert felled timber into manageable firewood, essential for heating and cooking in rural areas. The Bernard engine's reliability means fewer interruptions during work, while its relatively simple design allows for straightforward maintenance. Safety features, such as blade guards and stable supports, are essential when operating this equipment, as the rotating blade is extremely powerful. Overall, a Bernard engine-driven circular saw remains a valuable, time-saving solution for preparing firewood efficiently, especially in settings where electricity or modern machinery may not be readily available. The Ruston engine refers to a range of internal combustion engines manufactured by Ruston and Hornsby Limited, a British engineering company based in Lincoln, England. Founded in the mid-19th century, Ruston and Hornsby became a major producer of steam engines, locomotives, and later, oil and diesel engines that powered industries across the world. Their engines were widely used in agriculture, construction, marine propulsion, and electricity generation. Ruston engines earned a reputation for being durable, efficient, and reliable, qualities that made them especially popular in remote regions where machinery had to withstand tough conditions and limited maintenance support. They came in various configurations, from small stationary power units to large diesel engines capable of driving generators and heavy equipment. The company played an important role in the industrialization of the 20th century, supplying engines for ships, factories, and railways. Eventually, Ruston and Hornsby merged with English Electric in 1966, and its engine division became part of several corporate transitions, including GEC and later Alstom. Today, while original Ruston engines are no longer in large-scale production, many are preserved in museums and heritage sites, celebrated as an important part of Britain's engineering and industrial heritage. The one-cylinder Asa engine, produced around 1955 in Denmark, was a compact power unit widely used in agriculture, small industry, and as a stationary engine. Asa Motorfabrik, based in the town of Asa, specialized in robust, simple designs that could provide reliable power in rural environments where electricity was often limited. The single-cylinder layout kept the engine economical to produce and maintain, while still delivering sufficient output for tasks such as driving threshers, pumps, generators, and small boats.
Hvad er I gang med?
Typically, these engines were air-cooled, with a horizontal cylinder and low-speed operation that emphasized longevity over high performance. Fuel options varied, but many ran on kerosene or diesel, chosen for their availability and cost-effectiveness at the time. Starting was often manual, using a hand crank or decompression lever to ease operation. The Asa engine reflected the post-war demand for practical, durable machinery in farming and small-scale production. By 1955, electrification was spreading, yet many farmers and craftsmen still depended on reliable mechanical engines, particularly in Scandinavia's rural areas. The one-cylinder Asa was valued for its simplicity, ruggedness, and adaptability, characteristics that kept it in service for decades and made it a recognizable part of mid-20th century Danish agricultural heritage.
Andet forsøg. Remmen den røg af. Asa diesel. ASO.
The Ruston ship's diesel engine, newly arrived at the Stationary Engine Collection in Denmark in May 2016, represents an important piece of maritime and industrial heritage. Built by Ruston, a company long recognized for its robust engineering and reliable power units, this engine was originally designed to serve aboard working vessels. Ships' diesels like this one were valued for their durability, steady performance, and ability to run for long stretches under demanding conditions at sea. Its arrival at the collection expands an already remarkable display of historic engines that chart the development of mechanical power over more than a century. The stationary engine collection is renowned for preserving and showcasing engines from different periods, industries, and applications. The oldest machine on display dates all the way back to 1867, offering visitors a rare opportunity to trace the evolution of engine design from early steam and combustion principles to later, more efficient diesel technology. With the addition of the Ruston engine, the museum highlights not only the technical ingenuity behind marine engineering, but also the broader story of how engines shaped transport, trade, and everyday life. It stands as a testament to engineering progress and the dedication to preserving industrial history for future generations. The 1928 Alpha Diesel two-stroke hot bulb crude oil engine represents an important stage in the evolution of early marine and stationary power units. Built in Sweden by Alpha Diesel, a company known for pioneering compact and efficient marine engines, this model combined hot bulb ignition technology with a two-stroke cycle to deliver reliable performance on low-grade fuels, such as crude oil. Unlike modern diesel engines that rely solely on compression ignition, the hot bulb system used a preheated chamber to vaporize and ignite the fuel. This made the engine more forgiving in fuel quality, ideal for fishing vessels, small cargo boats, and remote applications where refined fuels were scarce. The two-stroke configuration allowed power on every revolution, giving the engine a favorable power-to-weight ratio, while its relatively simple mechanical design made it robust and easy to maintain. Operating at low speeds, it produced steady torque, suitable for marine propellers and agricultural machinery. By the late 1920s, engines like the Alpha became central to the mechanization of coastal shipping, replacing sail and oar in many regions. Though eventually surpassed by higher compression diesel engines, the 1928 Alpha Diesel two-stroke hot bulb engine remains a fascinating example of transitional technology bridging crude oil engines and the modern diesel era. The Big Deutz of 1930 stands as a striking monument to early heavy-duty diesel engineering. Built by Deutz, one of Germany's pioneering engine manufacturers, this massive horizontal single-cylinder machine displaced an extraordinary 67 liters. Designated as type MKH 260, it delivered around 80 horsepower, remarkable for the time, especially from a single cylinder. Originally installed at Aalborg Electricity Works in northern Denmark, the engine played an important role in keeping power flowing to the growing city. Its compressed air start system was necessary, as turning over such a huge piston by hand was simply impossible. The slow, steady beat of the Deutz became a familiar sound, embodying the reliability and endurance expected from industrial power units of the era. After its years in electricity generation, the Big Deutz found a second life at a sawmill, where it labored faithfully until 1972. That 4-decade span of service illustrates not only the engine's robust design, but also the value of such machines to industries far from their original home. The scale of the engine is impressive even today. One enormous cylinder, 67 liters in capacity, operating horizontally to reduce strain on moving parts and provide a steady output. Though modest in horsepower compared to modern engines, its sheer torque made it ideal for stationary work. The 1930 Big Deutz is more than a machine. It is a reminder of the ingenuity of early diesel pioneers, and a living piece of industrial heritage that helped power Northern Europe through much of the 20th century. The Antonov radial engine is a type of air-cooled aircraft power plant developed in the Soviet Union to meet the needs of rugged, versatile airplanes, particularly those designed by the Antonov Design Bureau. Radial engines, unlike inline or V-type engines, arrange their cylinders in a circular configuration around the crankshaft, which ensures effective cooling and reliable operation even under demanding conditions. This made them ideal for utility aircraft, cargo planes, and agricultural machines that Antonov was famous for producing. One of the most recognized engines associated with Antonov aircraft is the Shvetsov ASH-62, a 9-cylinder radial engine originally derived from the American Wright R1820. The ASH-62 produced around 1,000 horsepower and powered several Antonov designs, including the iconic AN 2-inches Colt, a rugged biplane that became one of the most produced aircraft in history. Its radial engine allowed the AN 2 to operate from short, unpaved runways and in extreme climates, from Siberia to Africa, without extensive maintenance support. The radial layout offered durability, simplicity, and the ability to keep running even if some cylinders failed, which was highly valued in remote operations. However, by the late 20th century, radial engines were gradually replaced by turboprops and turbofans due to their higher efficiency and lower weight-to-power ratios. Despite this, the Antonov radial engine legacy remains a testament to robust engineering, with many AN-2s and their powerful radial engines still flying today. These engines symbolize reliability and endurance in aviation history, particularly in challenging environments where few other aircraft could perform. The 36 to 120 twin-cylinder Rumely engine is a remarkable example of early American agricultural and industrial engineering. Built by the advanced Rumely company, this massive power unit was designed to provide reliable energy for heavy-duty applications, from threshing machines to sawmills. Rated at 36 horsepower on the drawbar and 120 horsepower on the belt, it earned a reputation for strength, endurance, and efficiency during the height of the steam-to-gas transition era. What makes this particular engine especially noteworthy is its rarity. Only 8 of these twin-cylinder Rumely engines are known to exist today. Each surviving machine is a prized artifact of farming history, representing a period when self-contained power was transforming rural life. The twin-cylinder design set it apart from many single-cylinder counterparts, delivering smoother, more balanced operation and the ability to tackle the toughest workloads. This engine has recently undergone a complete rebuild, restoring it to its original glory. Careful restoration work not only preserved its structural integrity, but also ensured that it runs as impressively as it did when new. Visitors to the 2013 Rice County Show were able to witness the engine in action, powering the sawmill with a deep, steady rumble that highlighted its mechanical precision. Both a working machine and a piece of living history, the 36 to 120 twin-cylinder Rumely engine stands as a tribute to early 20th century innovation and craftsmanship. Its presence at shows brings enthusiasts and spectators alike closer to the ingenuity that powered America's farms and industries over a century ago. The International Harvester 20 HP hit-and-miss engine was a massive stationary power plant built in the early 1900s to drive heavy farm and industrial equipment. Using the hit-and-miss governing system, it only fired when needed to maintain speed, conserving fuel and reducing wear. With 20 horsepower, it was among the larger models of its kind, capable of powering threshers, sawmills, pumps, and other machinery. These engines were built to last, with robust cast-iron construction and simple mechanics. Today, surviving examples are prized by collectors and displayed at antique engine shows, where their rhythmic chugging remains a symbol of early mechanization. The 1904 gas engine-powered water pump was an early innovation that combined internal combustion technology with practical utility. Unlike traditional hand pumps or steam-driven systems, this pump used a gasoline engine to provide continuous, reliable power for moving water. Farmers in rural communities especially benefited, as it simplified irrigation, livestock watering, and household supply. The engine, usually a single-cylinder model, was mounted alongside the pump mechanism, delivering rotational energy through a belt or direct drive. Its portability allowed it to be positioned near wells, rivers, or cisterns. Compared to steam engines, it required less maintenance, fuel, and startup time. The 1904 gas engine water pump marked an important step in mechanizing agriculture and improving everyday efficiency. The Marshall Britannia 16 HP portable steam engine is a fine example of late 19th and early 20th century British engineering, built by Marshall Sons and Company of Gainsborough, Lincolnshire. Known for their robust construction and reliability, Marshall engines were widely exported and became a symbol of agricultural and industrial progress across the world. The Britannia model in particular combined practical design with impressive horsepower, offering 16 nominal horsepower, which was more than enough to power threshing machines, sawmills, pumps, and other heavy-duty farm or factory equipment. As a portable steam engine, it was mounted on wheels and designed to be towed by horses and later tractors, allowing farmers and contractors to bring power directly to the worksite. Its design included a large horizontal boiler, a single-cylinder engine, and a tall chimney for efficient draft. The engine's portability and relative ease of operation made it invaluable in rural settings, where mechanization greatly increased productivity. The Britannia 16 HP also reflects the export-oriented vision of Marshall, with many units shipped to Europe, Africa, Asia, and Australasia. Today, surviving examples are highly prized by collectors and preservationists, often restored and displayed at steam rallies as enduring reminders of the steam age's ingenuity and craftsmanship. The Deutz gas engine A-Twin 1880 represents one of the early milestones in stationary engine development during the late 19th century. Built by the German company Deutz AG, a pioneer in internal combustion technology, this engine reflects the transition from steam power to gas-powered machinery. Designed as a twin-cylinder stationary engine, it was primarily used for industrial applications, such as driving machinery in workshops, mills, and small factories. The engine employed a slide valve system, a mechanism widely used in the early period before more advanced valve gear became common. The slide valve controlled the intake of the gas-air mixture and the exhaust process, ensuring relatively smooth operation. While less efficient than later poppet valve designs, slide valves were mechanically simple and reliable, making them suitable for continuous duty applications. The Deutz Twin was powered by coal gas or other available gaseous fuels, aligning with the era's push toward cleaner and more controllable alternatives to steam. Its stationary design emphasized durability, with a heavy cast iron frame and flywheels ensuring steady running. Engines like the Deutz A-Twin laid the foundation for modern power generation and industrial engines, marking an important step in the evolution of internal combustion technology. In the early decades of the 20th century, Manchester earned its place as one of the world's industrial powerhouses, not just through textiles, but also through engineering innovation. Among its most impressive mechanical achievements were the massive stationary engines produced by Crossley Brothers. Known worldwide for their reliability, Crossley engines powered factories, waterworks, mills, and municipal plants for generations. The huge Crossley stationary diesel engine was a marvel of scale and engineering. Often towering above the men who operated it, the engine featured massive cast iron flywheels, sometimes weighing several tons, and enormous cylinders designed for heavy continuous duty. These engines were not mobile. Instead, they were anchored permanently in engine houses, supplying steady power to drive line shafts, generators, or pumps. Their slow, rhythmic beat was the heartbeat of industry, and their robust construction allowed them to run for decades with minimal interruption. Crossley Brothers, founded in 1867 in Manchester, initially built gas engines but later moved into diesel technology, adapting Rudolf Diesel's revolutionary design. Their large stationary diesels combined efficiency with durability, making them indispensable during an age when consistent, reliable power meant industrial success. Today, surviving examples of these engines are preserved in museums and heritage collections, where their immense size and engineering presence continue to astonish visitors, serving as proud reminders of Manchester's mechanical heritage. A diesel engine motorbike is a unique type of motorcycle that runs on diesel fuel instead of the more common petrol. Diesel engines are known for their high torque, fuel efficiency, and durability, which make them attractive for certain types of riders. Unlike petrol engines, diesel engines compress air at very high pressures before injecting fuel, resulting in a more efficient combustion process. This allows a diesel motorbike to cover longer distances on less fuel, making it highly suitable for long journeys and heavy-duty use. One of the main advantages of diesel motorcycles is their impressive fuel economy. Riders can travel greater distances without frequent refueling, which is particularly useful in rural or remote areas. Additionally, the strong torque output of a diesel engine provides excellent pulling power, making these bikes ideal for carrying heavy loads or navigating rough terrains. Military forces in some countries have also adopted diesel motorcycles because they can use the same fuel as other vehicles in their fleet, simplifying logistics. However, diesel motorbikes also have some drawbacks. They tend to be heavier, noisier, and produce more vibrations compared to petrol bikes. Their acceleration is usually slower, and diesel engines are more expensive to manufacture. Despite these challenges, diesel motorcycles remain a fascinating alternative for riders seeking fuel efficiency, durability, and the ability to handle demanding riding conditions. Denmark's largest horizontal diesel engine is a remarkable piece of industrial history that reflects both the country's engineering skill and its reliance on robust machinery during the 20th century. This engine, with an impressive displacement of 67 liters, is a single-cylinder unit capable of producing 80 horsepower. Unlike modern engines that rely on electric starters, it was brought to life through compressed air start, a method common in large industrial engines of its era. The engine played a vital role in Denmark's energy supply and industry. For many years, it powered the Aalborg power plant, contributing to local electricity generation. Later, it found new life running a sawmill near Ebeltoft, where its strength and durability proved invaluable. This second chapter in its working life continued until 1971, when it was finally retired from active service after decades of operation. Today, this giant of Danish industry has not been lost to history. It is preserved as part of the Danish Engine and Machine Collection on Gersland near Grenaa. This museum holds Northern Europe's largest collection of historic engines, boasting more than 450 examples that chart the development of mechanical power. Among them, Denmark's largest horizontal diesel engine stands out as a symbol of both scale and endurance. The starting of such a machine was a dramatic event, compressed air rushing into the massive cylinder, followed by the deep, rhythmic beat of combustion. More than just a technical process, it marked the beginning of another day of work, powered by human ingenuity and mechanical force. The Wolsley antique motor from the year 1945 is a fascinating piece of engineering history that reflects both the craftsmanship and industrial spirit of its time. Built in the mid-20th century, this motor showcases the durability and ingenuity that Wolsley, a renowned British manufacturer, became known for. During that era, machinery was designed not only to serve practical needs, but also to last for decades, and the Wolsley motor is a perfect example of this philosophy. The year 1945 was especially significant, marking the end of World War II. Many machines produced during this period were built with wartime efficiency in mind, yet also adapted for peacetime applications. A motor like this would have been used in agricultural, industrial, or marine settings, providing reliable power when modern technology was far less advanced. Its solid construction, heavy cast iron components, and simple but effective design made it dependable under challenging conditions. Today, owning a Wolsley motor from 1945 is like owning a living artifact. Collectors and enthusiasts admire not only its technical design, but also its historical value. It represents the post-war era when industries were rebuilding and innovation was key to progress. Restoring such a motor allows one to appreciate the engineering skills of the past and to keep a small part of history alive. Whether displayed in a collection, preserved in a museum, or even restored to working condition, the Wolsley antique motor remains a testament to resilience, craftsmanship, and the enduring legacy of mid-20th century engineering. The RKMN3 stationary engine 10 HP, manufactured around 1929, is a fine example of early 20th century engineering designed for reliability and versatility. Stationary engines like this were widely used during the interwar years to provide mechanical power in agriculture, industry, and rural communities, where electricity supply was still limited. This 10-horsepower model reflects the robust construction typical of its era, with a heavy cast iron frame and large flywheels to maintain steady operation. The RKMN3 designation suggests it was part of a series intended to cover small to medium power needs. Engines of this type were often employed to drive threshers, water pumps, generators, saws, and other machinery, making them indispensable to both farmers and small workshops. Fuel flexibility was another advantage. Many engines from this period were designed to run on kerosene, diesel, or even gas, depending on availability. The slow revving nature of the RKMN3 would have allowed for efficient fuel use while reducing wear, a valuable feature in an age when machinery had to last decades. Regular lubrication and straightforward mechanical systems meant maintenance could be handled on-site with basic tools. By 1929, stationary engines like the RKMN3 represented a transitional phase between steam power and widespread electrification. Their role in mechanizing daily tasks contributed significantly to productivity gains in both rural and industrial settings. Today, surviving examples of the RKMN3 are prized by collectors and heritage enthusiasts, serving as a reminder of the ingenuity and craftsmanship of early internal combustion technology. The Baldwin Beexeen engine, produced by the Baldwin Beexeen Motorenfabrik in Altenburg, Germany, represents a notable chapter in early industrial engineering. Known for its robust stationary engines, the company contributed to agricultural and industrial mechanization in the late 19th and early 20th centuries. These engines were valued for their durability, efficiency, and ability to power machinery in factories, farms, and workshops. The Beexeen factory became a regional symbol of innovation and craftsmanship. Today, surviving examples of these engines are preserved and displayed at stationary engine meetings and heritage events, keeping the legacy of Baldwin Beexeen's engineering alive. Chat GPT Danoy, Wilhelm Friedenhagen of Offenbach, received German patent number 4116 in 1877 for a hot air engine, a variation of the Stirling engine. His design reflected the late 19th century drive to improve small, efficient power sources for workshops and household use. The engine featured a power piston, Arbeitskolben, with a diameter of 74 millimeters, and a larger displacer piston, Verdrängerkolben, measuring 130 millimeters, highlighting the classic Stirling principle of separating heating and working chambers. By moving air between hot and cold zones, the engine produced smooth rotary motion without combustion inside the cylinder. Friedenhagen's work represented both the ingenuity and practical experimentation of his era, contributing to the refinement of external combustion machines that offered safer and quieter alternatives to early internal combustion engines. The Farymann diesel Type D 6 HP stationary engine, also known as an evaporator engine, is a robust single-cylinder diesel engine designed for reliability and durability in stationary applications. Built in Germany, it represents the classic engineering approach of the early to mid-20th century, when engines were crafted for long service life under demanding conditions. Producing 6 horsepower, it was commonly used to drive agricultural machinery, pumps, saws, and small industrial equipment. One notable feature of this model is its ability to operate with a Bergmann direct current generator, delivering approximately 70 volts of power, often paired with 110 volts incandescent lamps. This made it a versatile choice for farms, workshops, and rural areas before widespread electrification. The evaporator cooling system added to its simplicity and ease of maintenance. Today, the Farymann Type D6 is valued by collectors and enthusiasts as a fine example of vintage German diesel engineering. The Goldner GK 5.5 HP stationary engine is a compact, durable engine designed for industrial and agricultural use. Equipped with a Natter vaporizer for efficient fuel atomization and an injection pump for precise fuel delivery, it delivers reliable performance, low maintenance, and consistent power for stationary applications. The Centaur gas engine, designed by Edgar T. Westbury, is a 60cc horizontal single-cylinder, 4-stroke internal combustion engine. First serialized in Model Engineer magazine in 1957, the Centaur showcases Westbury's expertise in model engineering. Notable for its open crank design and water-cooled system, the engine features a 1.5-inch bore and 2-inch stroke, delivering a compact yet powerful performance. Its construction emphasizes precision and craftsmanship, making it a favored project among model engineering enthusiasts. The Centaur remains a testament to Westbury's legacy in the realm of model engine design. The Cording Start diesel engine is a robust stationary engine designed for reliability, efficiency, and long-term performance in industrial and agricultural applications. Manufactured by Cording, a German company with a long-standing reputation for engineering excellence, this engine exemplifies precision engineering and durability. Its design focuses on providing a dependable power source, where continuous or intermittent mechanical energy is needed, without relying on mobility or transportation. As a stationary engine, the Cording Start diesel engine is typically mounted in a fixed location and used to drive machinery, pumps, generators, or compressors. Unlike mobile diesel engines, stationary engines are optimized for steady operation over long periods, often under heavy loads. The diesel combustion system ensures high thermal efficiency and fuel economy, making it suitable for applications where cost-effective, continuous operation is critical. One of the key features of the Cording Start diesel engine is its starting mechanism. Designed for ease of operation, it allows for reliable ignition even in challenging environmental conditions. Its robust construction includes high-quality castings, precision-machined components, and a durable fuel injection system, which together minimize maintenance requirements and extend service life. The engine's design also emphasizes vibration reduction and smooth operation, ensuring safety and stability during prolonged use. Cording's commitment to quality is evident in every aspect of the engine, from its corrosion-resistant materials to its carefully calibrated fuel and air systems. Its versatility allows it to be integrated into various industrial setups, including waterworks, factories, agricultural processing, and backup power systems. The Jenbacher JW15 is a stationary engine showcased in Prum in 2019, representing a notable development in industrial engine technology. This versatile engine can operate as a vaporizing engine or in diesel mode, highlighting its adaptability to different fuel types and operating conditions. Designed for stationary power generation, it emphasizes efficiency, reliability, and low emissions, making it suitable for decentralized energy production. The JW15 reflects Jenbacher's engineering focus on combining robust mechanical design with advanced combustion technology. Its appearance at Prum 2019 demonstrated its potential for industrial applications, particularly in energy sectors seeking flexible, high-performance engines. The Deutz MAH914 is a historic diesel engine series produced by the German manufacturer Deutz AG, renowned for its robust design and reliability. Introduced in the mid-20th century, the MAH914 series was primarily utilized in agricultural and industrial applications, including tractors and stationary machinery.
Die Reglerfalle bzw. die Dekompression habe ich schon reingedrückt, das Video nicht allzu langweilig zu machen.
The MAH914 engines are characterized by their horizontal, air-cooled configuration, typically featuring a single-cylinder layout. This design choice contributed to the engine's compact size and ease of maintenance, making it suitable for various operational environments. The engines were built during a period when Cologne was occupied by the Americans, or shortly thereafter, reflecting the post-war industrial landscape. Over the years, the MAH914 series has become a subject of interest for vintage engine enthusiasts and restorers. For instance, a user on a forum shared their experience of restoring a Deutz MAH914, seeking information about specific parts and maintenance procedures. Additionally, operating instructions and spare parts lists for the MAH914-916 models, dating back to around 1940, are available for those interested in the technical aspects and upkeep of these engines. The Deutz MAH914 diesel engine series stands as a testament to mid-20th century engineering, offering insights into the technological advancements of its time. Its enduring presence in the vintage engine community underscores its lasting impact and the continued appreciation for its design and functionality.